Hello everyone. We are going to see the execution of linear regression using Python coding in Colab. Colab is an open source, and here I have opened the Colab. You must keep your Gmail open and type in the Google Colab. So when you click this, and you can select the file new notebook, and here is the coding page where you can type each line to execute. And now this experiment is with Boston housing prices related data set, and we are going to apply linear regression on this Boston housing data set. And we have to import that file. I have a file called Boston housing. This CSV file. This is a CSV file. I am going to import this into the Colab. And the procedure for importing inside the Colab, you click on this folder symbol on the left side. Folder symbol on the left side. You wait here until browse option comes here. Until browse option comes here, we have to wait. Then we have to select this browse option, and wherever your file is there in the desktop, browse and get that. And it once you close the program, this dataset will go. Until you are working with this page, this dataset will be available. This is .xls file. Just 1 minute, I will go with CSV file. This is CSV file. Boston, this is CSV file. So I will just import the CSV file, Boston CSV file inside the Colab, and I will remove this XLS file. Now I am going to import the libraries. I am going to import the libraries. These are the libraries together in one stretch. I am just importing pandas, numpy, cbon, matplotlib. So matplotlib and cbon both are used for plotting. In some cases, cbon library is used for plotting. So all the libraries I am importing. Now this is the, you have to click on code. So next line will come for typing the coding. And now this is not from desktop. So just I will right click this file, copy path, and then I will put it here, so that the file which is available, the file which is available inside the Colab, it will be connected to the program. And we have Boston, means we are going to visualize the plot. Visualize the data inside the file. These are the columns available inside the file: CRIM, ZN, index, all this. Now I am going to print the top 5 rows. So this is the command for top 5 rows. You have to click on code, then plot the first 5 rows. You can see first 5 rows only will be plotted, same headings. Now next line, last 5 rows means tail. Boston, last 5 rows we want to print, then it is tail. So I have clicked somewhere. I will remove this line, edit, delete selected cells. I want after this line, after the head. So code. Next I am going to get the last 5 lines in the Boston dataset. These are last 5 lines. You can see up to 505 it is there. And describe means what are the data present inside the dataset. So Boston is the name of the dataset. Dot describe, dataset name followed by describe means it will give what are the headings available, what are the columns. It will also calculate mean, median, standard deviation, all that. Describe function will do all this. Next, just visualizing some plots will help us to understand the relation between the variables. So we are going with the distribution plot, and the cbon library is used for plotting the distribution plot, and the price is one of the column. So I am using distribution plot, cbon library, distribution plot, and this is the distribution plot for price versus density. Next line coding. This plots are optional. It is not compulsory you have to do all the plots. Applying linear regression is very important. Now dot corr is the correlation function. It is available in pandas library. In pandas library itself, correlation corr is available. It will give the linear relation between the variables present. And then heat map is the function. Heat map is the function to plot the correlation matrix. So this is for calculating the correlation. CORR is for calculating the correlation. Heat map is for plotting the correlation matrix. So now I am going to copy paste these two lines. One is for calculating the correlation and secondly plotting the correlation matrix. Now you can see this is the correlation matrix. X-axis, Y-axis, you can see all the variables that were present inside the dataset, Boston dataset. It is finding correlation between each and every variable with each and every variable in that. If the value is +1, it is more correlated. If it is -1, it is negatively correlated. +1 means positive correlated. -1 means negative correlation between the variables. Okay. So +1, -1. So you can see diagonally 1 means x-axis RM, y-axis also RM. Then it is diagonally 100% correlation. Next, I am going with dividing the data set into X array and Y array. Only then we can apply the regression. We are dividing the data set into X array, Y array, and L stat, RM, these are the columns. Price is also one of the column. So we are training the model. We are training the model. Next is splitting the data into training and testing. We are going with 80% training and 20% testing. 80% training, 20% testing. If you put dataset dot shape, how many rows, how many columns are there, it will all show you. In the beginning itself, we should have done that to find the number of rows, columns in the Boston dataset. And now 80% training, 20% testing we are applying. After that, the X array, Y array, you can see this is 80%, 20%, 80%, 20% are there. Next, we are going with importing the linear regression. So sklearn is the library where linear regression is available. And then we are designing the linear regression model. We are designing the linear regression model. We are importing linear regression from the sklearn library, and then we metrics. What are the performance metrics we want? Mean square error, root mean square error, and R square. These metrics we want. We are designing the model. X train, Y train. We are applying linear regression function. We are applying, and we are storing in the variable lin underscore model. After designing the model, we are storing in lin underscore model variable. We have the linear regression model. Next, we will evaluate the model. We will evaluate the model. So we are evaluating using training data set. After that, we will evaluate using testing data set. Training is 80% data. After designing the module, we are applying the training data set, and then we are going to evaluate the model. So here we are importing the performance matrix R square, and here dot predict. This is the prediction we are doing. And then we are applying Y train predict, and we are calculating MSE mean square error, root mean square error, and R square. These three parameters for training data set, 80% data set only we are applying, and then we will be getting all the three parameters. So actually the root mean square error and R square both will give how well the regression model is fitting the data set, and root mean square value will tell the response variable in absolute terms, whereas R square will tell in terms of percentage. It will predict the value of response variable in terms of percentage. R square will predict in terms of percentage. Root mean square error will tell in terms of absolute value. This is the difference between root mean square and R square variable we are using, and training 80% data set we are applying, and we are getting the values of MSE, RMSE, and R square. Now we will apply the testing data set. we will apply the testing data set and evaluate. 20% testing we have data set, and then we will evaluate that 20% using the linear regression model. So 20% we are applying testing data, and the same mean square error, root mean square error, and R square we are calculating. We are applying Y test predict, X test in the prediction. And these are the values we are getting in terms of testing. When we apply 20% data, we are getting testing parameters, testing parameters. So with this, linear regression is completed. We have applied it on the Boston housing price data set. Using colab, we have implemented this. Thank you.